Here are 10 examples on proving trigonometric identities and learning different strategies. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this particular video, we'll discuss trigonometric identities further. Well, in part 1 of trigonometric identities, we understood what are these trigonometric ratios, how are they related, and we also proved the Pythagorean trigonometric identity of sine squared theta plus cos squared theta equals to 1 plus tan squared theta equals to secant squared theta, and 1 plus cotangent squared theta equals to cosecant squared theta. Apart from that, we looked into the quotient and the reciprocal identity. Now in part 2, we are going to practice with some examples. We'll take up examples to prove identities using x, y, and r, which are points in the coordinate plane. We'll identify the identities, prove identities, and state restrictions. Identities with primary ratios and with secondary ratios will be taken. We'll have some examination style practice with a challenge question. I hope you'll find it interesting and useful. So let's begin with the very first set, where the question is, prove the following identities using x, y, and r, state restrictions. So there are two parts to this. So when I say x, y, and r, it really means we are relating to a point in a coordinate plane. Now, how are these x, y, and r helping us to find the solution? Well, if I enlarge this portion of the triangle here, how will it look like? Let's look into this. So basically, we have a triangle where the center is the vertex, center O, point P, right? Angle, principal angle, theta. When the coordinate point P is xy, it really means what? That the distance from O to, let's say this point is Q, is x, and the distance from P to Q is y. And O to P is basically r, which can be related with x and y with Pythagorean theorem. R square equals to x square plus y square. Is that clear to you? Now they help us to prove the identities. Let us see how one by one, right? So the very first one is cotangent theta times sine theta is equals to cos theta. Now, whenever you want to prove the identities, we need to start from one side and prove that it is equal to the other. So let's begin with the left-hand side. So on the left-hand side, we have cotangent theta times sine theta. Now, in this particular triangle, which you see here, point P with x and y, what is cot theta? Well, cotangent theta is the ratio of OQ to OP, that is to say x over y, correct? So we can write cotangent theta as a ratio of x over y. And here, what is sine theta? Well, sine theta is the ratio of opposite side, which is y here, right? This is x and that is r, correct? Y over r. So when you multiply them, what do you get? Well, we can cancel y's, right? And clearly, what we get is equal to x over r. Now x over r is adjacent side over hypotenuse, which is equal to cosine theta. Clear? So that is how we are showing that the left hand side is equal to the right hand side, and hence we have shown that the identity is perfect, correct? Now the second part of this question is state restrictions. How do we state restrictions? Well, let's rewrite. We are given cot theta times sine theta equals to cos theta, right? So what is cot theta? Well, cot theta is the ratio of which? Cos over sine, right? So it is the ratio of cos theta over sine theta. Clear? Now, since sine theta comes in the denominator in this particular case, it cannot be equal to 0. And therefore, the restriction here is what? Can you tell me? Clearly, that sine theta is not equal to 0. Because if sine theta is equal to 0, then cotangent theta is not defined. Perfect. So that is an restriction on this particular case. Now I hope the concept is absolutely clear. I would like you to answer question number 2. So in question number 2, we can again begin with left hand side, which is cosecant theta times sine theta. And what is cosecant theta? Ratio of r over y, right? And sine theta is y over r. So clearly they cancel and we get 1, which is same as the right hand side. And so we have shown that left hand side is equal to the right hand side. Now let's get back to the restrictions. So can you tell me what are the restrictions in this particular case? Well, clearly the restrictions are that the denominator cannot be 0, right? So when I write cosecant theta times sine theta, then cosecant theta is actually 1 over sine theta, right? So and we have times sine theta, and we know this is 1. Clearly the restriction is that sine theta is not equal to 0 because you cannot divide by 0. You get the idea. Well, this is also a way of showing or proving the identity. Since the question demanded that we have to use x, y, and r, the approach is absolutely clear, right? Question number 3. So this time we have to prove the identity 1 equals to secant square theta minus tan square theta. Let's start with the right hand side this time, since it is more complicated. So right hand side is secant square theta minus tan square theta, correct? Now secant is a ratio of, let's write down, see I think you understand, we are using this triangle, correct? So secant is reciprocal of cosine, so it is r over x, correct? So we'll write this as r over x, both are squared, so we'll square it, minus tan is the ratio of y over x, so it'll be y square over x square. Now that gives me x square as a common factor in the denominator, and we get r square minus y square. Now what is r square minus y square? Let's look into that part. You know, x square plus y square is equal to r square, and therefore x square is actually equal to r square minus y square. So I could write r square minus y square as x square, and so we have x square over x square, which is indeed 1, or the left hand side. You get it, right? So that is how we prove this particular identity using x, y, and r, straightforward. So this is a very effective approach for proving identities, correct? Now, the last part here is to write down the restrictions. So in the case of restrictions, we know very clearly that secant has cosine in the denominator and tan also, right? So we can write down this identity as 1 over cos square theta minus sine square theta over cos square theta. So clearly in this case cos theta should not be equal to 0. So that is the restriction. Is that clear to you? So in the first 3 questions, or rather the first set, we have understood how do we prove identities using x, y, and r. Also, these identities are true in their own domain and they may have restrictions. Restrictions are when the denominator is equal to 0. Clear? Let's move on to the next set of questions, which is factor each expression. Now, in proving identities, factoring is one of the most important things. We'll not only factor these expressions, but we'll also understand how are they helpful. So that is in addition to just factoring. So we have 1 minus cos square theta. How will you factor it? Well, you know, a square minus b square is what? It is equal to the product of sum and difference, right? So this is what we are going to do. So 1 minus cos square theta can be written as 1 plus cos theta times 1 minus cos theta, correct? So that is how we factor, and this will help us to prove many identities. We'll see some of them in this part also. Also remember one thing, and that is, you remember trigonometric identity, right? So recall that sine square theta plus cos square theta is equal to 1. So in that case, 1 minus cos square theta is actually sine square theta, correct? So sine square theta is 1 minus cos square theta, which can also be written as 1 plus cos theta times 1 minus cos theta. So that is going to help you later in proving identities. Now let's look into the second. We have taken this as a simple exercise on factoring, but it has much more to it, right? So this time we will see how do we factor secant square theta minus tan square theta. Clearly, we are going to use difference of squares, and it can be written as secant theta plus tan theta times secant theta minus tan theta, correct? Also remember the identity which is related to it, and that is 1 plus tan square theta is equal to secant square theta, correct? So if you look at it, then actually speaking, 1 is equal to secant square theta minus tan square theta. Now which we have shown is product of secant theta plus tan theta times secant theta minus tan theta, correct? Now this is very important. We could write secant theta plus tan theta as equal to what? As 1 over secant theta minus tan theta. You get the idea. So this is a huge property which can help us prove many identities. So the idea of taking this particular question in between was to show you that how powerful this particular factoring can be and how at many times it can help you solve some difficult questions. Perfect. Now let's get on to some real trigonometric identities. Now show that the right hand side is equal to the left hand side. That is what we mean when we say prove identity. Is that clear to you? Perfect. There are 4 questions which you need to do. You can always pause the video, answer, right? I hope you're getting all these concepts. Feel free to write your comments and share your views. In case you want to learn directly from me, send an email on the address given, or also check our website for the latest updates. Now let's look into the solution of these questions one by one. Here is the very first one, which is 1 plus tan theta over 1 plus cotangent theta equals to tan theta. How do we solve this? Well, remember, how can you write tan theta? Tan theta is a ratio of sine theta and cos theta. Now that is the quotient identity, correct? We can use this to prove the identity. Well, some of you can also use the identity that cotangent theta is equal to 1 over tan theta. So there are many approaches to this particular solution. You may adopt any one of them. However, I'm going to adopt the first one, right? So we'll start with the left hand side since it is more complicated and is given as 1 plus tan theta over 1 plus cotangent theta. Okay, so I'm writing them in terms of sine and cosine. So I can write this as, let me change the ink here, right? I'll write this as 1 plus tan as the ratio of sine theta over cos theta, right? And cotangent as a ratio of cos theta over sine theta. So let's take common denominators. So we get cos theta plus sine theta over cos theta in the numerator. And in the denominator, we get sine theta plus cos theta over sine theta. Clear? Now this is as good as writing cos theta plus sine theta over cos theta, and the denominator we are going to flip and rewrite. Clear? Now here you can see that cos theta plus sine theta can be cancelled, and therefore we get a result which is sine theta over cos theta. And what is sine theta over cos theta? It is tan theta, which in our case is the right hand side. So we have shown that left hand side is equal to right hand side, and that is how you prove it. Perfect. Let's move on and take the next question. It is 1 plus sine square x over 1 minus sine to the power of 4x equals to secant square x. How do we do it? So we are going to use one of our skills which we just learned, and that was factoring. Do you see that? We can factor the denominator. So we'll begin with the left hand side, right, which is 1 plus sine square x over 1 minus sine to the power of 4x. Now, numerator, let's write as such 1 plus sine square x. But the denominator, I'm going to factor as product of sum and difference. So we get 1 plus sine square x times 1 minus sine square x. Clear? Now we see that 1 plus sine square x cancels, and so we get what? We get 1 over 1 minus sine square x. Now what is that equal to? Well, that is equal to 1 over cos square x. How do you know? Well, very clearly. We know that sine square x plus cos square x is 1. That is the Pythagorean identity. And therefore, we can take sine square x to the other side, leaving cos square x as equal to 1 minus sine square x. Is that clear to you? So that is how we do it. And using the reciprocal identity, I can write 1 over cos square x as secant square x, which is the right hand side. So once again, we have shown that left hand side is equal to right hand side. Hence, the identity has been proven. Perfect. So that is how you should be doing it. Here is the next question. I'd like you to pause the video, answer this question. We have square root of 1 plus cos x over 1 minus cos x is equal to absolute value of 1 plus cos x over sin x. So let's begin with the left hand side, which seems to be more complicated. We have square root of 1 plus cos x over 1 minus cos x. Now, whenever you get square roots, it's a good policy to rationalize, right? So we have 1 plus cos x over 1 minus cos x within square root. Let's rationalize, multiplying with 1 plus cos x. We are rationalizing the denominator over 1 plus cos x. Clear? So, in the numerator, we have 1 plus cos x, 1 plus cos x, which becomes square, right? So we have 1 plus cos x whole square when we multiply the numerator. And in the denominator, we get difference of squares, 1 minus cos square x, right? Now, so we have this as 1 plus cos x whole square, right? I'm not opening the square root yet, but 1 minus cos square x, we also saw recently, it is sine square x, correct? So square root of square is the number with absolute value. And so we get 1 plus cos x over sine x, absolute value, which is the right hand side. And that is how you can prove it. Is it clear to you? Perfect. Now here is the next question, question number 9. Sine square x equals to 1, sine square x over 1 minus cos x equals to 1 plus cos x. How will you do it? We want 1 plus cos x on the right hand side. So we'll start with the left hand side, correct? Left hand side is sine square x over 1 minus cos x. Well, clearly, I could multiply and divide by 1 plus cos x. What happens? Let's see. So we have sine square x over 1 minus cos x. I'm going to multiply with 1 plus cos x and also divide by 1 plus cos x. Now that gives you what? Let's rewrite. So we have sine square x times 1 plus cos x in the numerator, and the denominator is 1 minus cos x times 1 plus cos x, which is 1 minus cos square x, right? And that is sine square x times 1 plus cos x over, what is 1 minus cos square x? It is sine square x, right? Perfect. So sine square x and sine square x cancels. You are left with what? 1 plus cos x, which is the right hand side, and that is how we are going to prove this identity. Clear? Simple approach and very effective approach to solve such a question. I hope you're getting all these concepts. Feel free to write your comments, and in case you want to learn from me, send an email on the address given. Solution of question 10 and 11 will be shown in the next video. Thanks for your time and all the best.